So I'm Steve Ickman with Fuse Labs, and I'd like to welcome everyone to our second TypeScript Meetup. Before we get started, just a quick show of hands. Who here is actively working on a project using TypeScript? Wow, most of the... Who here is not currently using TypeScript but is like evaluating? So those are the guys you guys need to mob right? sometime during the course of this event. So the goal of this event really is kind of twofold. It's basically one, to let the TypeScript team kind of give us an update as to what's happening with the language, where things are going. But it's also about learning what teams are currently using TypeScript in the company and just meeting people and socialize. So last time we did this, the agenda was kind of stacked to where we basically had a whole bunch of talks, and we had like a 50-minute kind of like socializing session at the end, which hardly didn't happen, thanks to the Q&A panel running like massively over. So this time I kind of planned for that, and I basically broke it in half, right, to allow a little bit of buffer in between here. So we're basically going to start off by just doing this around the room introduction. We do this thing, and I'm going to give you a minute to think about it. So you just give your name, like what group you're with, and think of 3 tags that basically describe you. And we'll pass the mic around for that. And then Anders will give us kind of like an opening set of comments. And then we'll get a talk from Erich Gamma, who is currently remotely in, I guess he's in the UK? He's in Zurich, Switzerland. So he's like 9 hours ahead of us. It's almost midnight for him, or it is midnight. And so we'll let him get his talk out of the way first. This is going to be a talk that he just gave at JSConf, is that correct? On TypeScript and the trenches, and then Luke will give us an update. We'll do another Q&A session, which I hope is as awesome as the last one was. Take a break, and then we'll come back for a series of talks that I've already looked at some of these, and they're pretty awesome. So I hope everyone stays around to catch the afternoon talks. And the whole thing should wrap up around 4:30 if we're on time. But we have the room all the way till 6. But if people have to duck out because you have to catch connectors and stuff like that, I understand it. I added like 30 minutes onto the event this time. So anyway, with that, let's start passing the mic around. So I'll go first. I'm Steve Ickman. I'm from Fuse Labs, and my 3 words are programming, music, and movies.
Jonathan Turner. I guess my 3 words are program, manager, TypeScript.
I'm going to go with Steve Lucco, and I'm just going to go TypeScript, TypeScript, TypeScript.
Hi, Dan Rogers. I work with Xbox Music. I guess I would say music, father, and gamer.
Erich Hejlsberg. I work on TypeScript too. I love TypeScript.
There's already a TypeScript too.
I'm sure there will.
Luke Hoban, also work on TypeScript and JavaScript. I'd say developer tools, languages.
I'm Samuel, out through web access. My 3 words would be web, docs, and script sharp.
Hi, I'm Harmony. I work with Outlook Web Access, intern. Yeah, I'll just go with that.
Hi, I'm David Stevens. I'm a PM intern on TypeScript, and I'd have to go with Nebraska, intern, and TypeScript. How about that?
Hi, my name is Kiran. I am a developer at Bing, and my 3 words are Bing, JavaScript, and TypeScript.
Hi, I'm Sarvesh. I also work at Bing, and my 3 words would be same as his, JavaScript, TypeScript, and Bing in that order. Okay, I'll add cricket.
My name is Monica. I'm working on the Data Lab team. 3 words: Australian, food, and cats.
Hi, I'm Milan Tomic. I'm on the Data Lab team as well. My 3 words would be TypeScript, Sun, and C.
I'm Randy from the Data Lab team. I'm going to go with infrastructure, and demos.
I'm Rit from the TypeScript team, and I'm going to go with Ninkasi Total Domination. Kevin Dev on Data Lab team, data, science, UX.
Where are we going next? Let's go this way and then we'll make it.
I'm Timothy. I'm from MOD China. So 3 words are TypeScript, telemetry, funny.
Bennett MSR, Research Languages Security.
Judith Bishop from Microsoft Research Connections, so it'd be Touch Develop, Academics, and C#.
Wolfram Schulte, Tools for Software Engineers, Build Systems, Engineer Productivity.
I'm Paul Vick from the JavaScript team, Programming Languages JavaScript.
I'm Ron Buckton from Visual Studio Cloud Services, and my 3 words would be father, developer, and gamer.
Aaron from the Data Explorer team, UX, data, programming languages.
My name is Eamon, and I work in the Windows Phone team. I think random, web, and mobile.
I'm Rajiv. I'm an SD in the Fuse Labs team. My words are programming, graphics, and user experience.
I'm Song with Fuse Labs. My 3 words would be UX, art, and science.
Hello, my name is Hai. I'm with developer with Fuse Labs, and 3 words will be jQuery, Node.js, and mobile.
Hi, I'm Yui. I'm intern in TypeScript team. I don't have 3 words yet. So.
Come on, try.
TypeScript, Thailand, and Pennsylvania.
My name is Mohammed, and I work on the TypeScript team. And my 3 words, I guess, JavaScript, TypeScript, and language service.
My name is Raphael. I'm a new intern on the Touch Develop team, and my 3 words are Brazil, Touch Develop, and intern.
I'm Cyrus. I'm a developer on the TypeScript team, and I am a driven, dedicated developer.
I'm Sunny. I work with Microsoft IT Discovery and Collaboration team. We take care of Windows 8, Windows Phone 8, internal app publication, and tools. My 3 words would be Windows Phone 8, Windows 8, and certification.
Yeah. So I'm Devras. I'm a Windows Phone 8 and Windows 8 app developer. And my 3 words would be Windows 8, Windows Phone 8, and TypeScript.
I'm Todd Newman. I'm one of the developers on the Fuse team, and my 3 words would be your message here.
I'm Yao. I'm from MODC. It's from China, and my 3 words is Excel, Office, apps.
Okay, I'm Bin from Office Ecosystem team. And okay, my 3 words are thinking in TypeScript.
This is Jen from the Office team. My 3 words is Office, apps, and the ecosystem.
My name's Chris Dias from the Monaco team. I'm the program manager on the Monaco team. I guess my 3 words would be pizza, beer, and Monaco.
I'm Abby Gregory. I'm also on the Monaco team, but I'm a intern. And I'll go with intern, London, music.
I'm Charles Willis. I'm on the Monaco team. I'm PM intern, and my 3 words would be cycling, teaching, and dev tools.
Chris McConnell, I'm a dev lead in Fuse Labs. 3 words for me are search, performance, and salsa. Not buzz. Yeah.
My name is Christopher Benage. Hello. Good morning. I am a developer on the Patterns and Practices team here at Microsoft. My 3 words are curious, distracted, and learning.
I'm Madeline. I'm a PM intern on the Patterns and Practices team, and my 3 words would be computers, books, and puzzles.
Hi, I'm Julian from the Patterns and Practices team, and my 3 tags, not words necessarily, are programming, passion for learning, and gaming.
I'm Mads. I'm on the Managed Languages team as a PM, and my 3 words are programming, language design.
We got some people that just came in, and this is Stacy, our admin that organized the bulk of this. All I did was send emails around, so thank you very much, Stacy. Who just
I'm Nick Swami. 3 words, I suppose, are functional programming verification.
Hi, I'm Savas Parasatidis, architect in OSD. In 3 words, I was late.
Oh, it's just 3 tags that described you.
3 tags.
We're making up 3 random ones.
Yeah, I know. Programming, large-scale systems.
Perfect.
Carl Persa, JavaScript, cross-compiling.
Awesome. Okay, so a couple of things I forgot before we move into Anders' time. We're also recording this and streaming it online. I'll send out links to the recordings later. Slight programming note. We're going to be, I had to rearrange the afternoon talks a bit because there's some Windows Blue features that are going to be demoed that we don't want streamed or recorded. So unfortunately, if you're online watching this, you're not going to get to see that. You should come to the event. Right. But last time we had like 50 people watching online, which was amazing. So like add that to this. I would say that we're already quite a bit above the number of people that we had attend last time. So it's really amazing statement to the popularity of this language. So Anders, all right, take it away.
I thought I'd start with just saying thank you. Thank you for being here. I mean, this is great to see so many people here compared to the last time where we just had a couple of tables, and obviously we're getting some more adoption. I want to thank you for betting on our work. You know, I want to thank you for the feedback that we get from this internal community, which is just invaluable. And it allows us to be really fast turnaround on making the language better. And I know that it costs you a lot of time to deal with our bugs, but we do really appreciate it. So thanks. I don't have. I have 2 slides. I thought I'd talk a little bit about. I mean, we were obviously witnessing that a bit of TypeScript momentum here with so many more groups this time around. I wanted to talk a little bit about what's happening outside. We started officially this project in October of last year, so we're about 9 months old at this point, and we've seen a lot of growth. It's actually even surprised me. I think I hadn't really expected it to be as much as it is. I think are we the most busy site now on Coplex, or I think activity-wise, sure, or at least for the first couple of months. Yeah. More than 3,000 discussion posts, lots of forks, lots of activity on Stack Overflow, lots of feature requests. A thing that none of us had expected was the sort of ecosystem take-up around creating declaration files for existing JavaScript frameworks. A guy named Boris Yankov started a site on GitHub called Definitely Typed that basically is a repository of all of the declaration files that people have written for existing JavaScript frameworks, and they're close to 200 now, and they cover in excess of 90% of all the popular JavaScript frameworks, albeit with varying quality, but some of them are pretty darn good. And it's nice now to see that some of the authors of those frameworks are actually like starting to chip in and help improve the quality of the declaration files, and all of this happened without any involvement on our part, which is just very interesting to watch. Having just spent my entire career doing closed source development, you know, and then just sort of see the power of open source there. We're seeing a lot of tool support in the community. IDEs, in particular, are starting to support TypeScript as a major language, and I think we really made the right choice by not just making a compiler open source, but also the language services that power all of the IntelliSense and refactoring and go to definition and so forth that we have in Visual Studio is all written in TypeScript 2 and all part of the open source deliverable. And people are indeed picking that up and using it in their editors. And an interesting fact, I was just looking at Jonathan's post or a little newsletter there that it appears now that we are seeing more downloads from non-Microsoft platforms of TypeScript now than Microsoft. We actually have more NPM downloads than Visual Studio downloads at this point, which is you know, I think wonderful because that's really sort of how, you know, we're going to be a viable player. So TypeScript 09 is, we have an alpha release out, or a beta, I suppose it's now, and we'll have a final beta or of 09 in a couple of weeks, or less than 2 weeks, before build, a little bit before build. And that's sort of our final major milestone before 1.0, which we're targeting for the fall. The big headliner in 09 is generics. How many of you have already played with the generic support in TypeScript? A few. Okay, surprisingly few. Okay. It's the top requested feature on our issue tracker. Second most requested is async, but we're not going to go there in 1.0. And it basically allows the type system to be much more expressive. It allows you to better and more accurately model what happens with types as they flow through signatures, you know, and like functions, and then what does the functions return, and then so on. We also have a bunch of smaller features, like one is overloading on constants. I don't know, are you going to show examples of some of these? Or yeah, okay, Luke will show some examples. Enum types, export equals, et cetera, et cetera. The compiler is pretty much a complete rewrite for 0.9, and I think those of you who've already used it will, modulo bugs, will note that the IDE performance has gotten dramatically better because we now have an incremental architecture. We will incrementally parse source code and incrementally update the parse trees. We have a pull model type checker, which means that we can compute just as much type information as we need to in order to give you, say, a completion list or whatever. And that means that we can scale to much larger projects in the IDE without you just sort of sitting there waiting for stuff to happen. Currently, performance of the batch compiler is slower than the 08 series compilers. We know that, and we will fix that. And I think our commitment is basically to reach 0.8 performance by 1.0, at least, for batch compiles. But certainly the IDE, you should see much, much better perf. I wanted to maybe just briefly show what generics look like in action. Here's a little function that uses some of the ECMAScript 5 new methods on arrays, like map, filter, reduce, and so forth, these functional methods that have been added to array. First here, you know, I don't have any type information. If I first modify my sample here to say element names is a string array, you'll note that, well, first of all, an error shows up down here that with 08 wouldn't have shown up because map, for example, and the map function on array just returns any because we can't accurately describe how types flow through a mapping function and into the output array and so forth. But now we can, and in fact, we can trace it all the way to the end here and figure out what the correct types are. So I can first of all modify that, and now we have actually here correctly inferred that this thing returns a number. But the way we've inferred it is by using generics. If I go to the definition of map here, you'll see that first of all, array is now declared as a generic type. It's an array of t's. And that allows us then, in turn, to have a whole bunch of methods that take t's or return t's. But then there's even a method like map, which is a generic method that introduces yet another type parameter and takes a callback function that takes a t and returns a u, and then map in turn returns a u array. And there's a filter, and there's a reduce, and there's all of those. And we can actually through this code, completely flow types such that we know elements names as a string array, and therefore we know that this get element by ID returns an HTML element, and therefore we have an HTML element array here, and filter also produces HTML elements, and then we map that through and pick out a property, and that gets us a number array, and then we call reduce, which reduces our number array to a number. And it's all just flowing, and I didn't have to add any type annotations here. So that's, in a sense, the power of generics. It's not, generics are used, in a sense, differently here than they are in C# and .NET. In C# and .NET, one of the prime motivators there, of course, it's typing, but it's also performance, right? Because we can generate specialized code and so forth. We don't do that here. But we definitely take advantage of the ability for generics to accurately model how types flow in APIs. Okay, with that, I think we're already way behind, so I'll shut up and we'll move on to is it Erich? Yeah, next here.
Yes.
Yeah. All right. So I'll pass it off to Erich, and then we can do more Q&A, and Luke will show you more about this stuff too. Yep.
Okay. So I will also do the city exercise. So I would say Monaco, what I work on; Zurich, where I am; Revelstoke, where I'd like to be, in particular during the winter because of the great snow. Another cool place I was a week ago was Omni Island, Florida, where JSConf took place, which is a very interesting conference because it's lots of cool people. They're all from startups, from Twitter, from Facebook, from New York Times, or other things. So they're really cool, deep into JavaScript. And I also did the show of hands exercise. The good thing is everybody knew TypeScript. But when it came to how many are doing projects with TypeScript, they were much less cool than the audience I talk to now because very few hands go up. So it looks like I'm talking to a cooler audience today. Okay, so this is the talk I gave there, and not exactly in the same form. I show you more than I show them, right? For instance, I didn't show them Monaco. I didn't show them the Monaco workbench. So I want to show you more, and also I don't do the TypeScript introduction stuff that I greased in to sell it. So my goal of the talk was that the TypeScript downloads should go up significantly after the talk. I haven't tracked it. So it was about application scale JavaScript, which means our experience from using TypeScript. We were one of the first adopters from almost since I joined Microsoft. I worked with TypeScript, as it was called. So application scale, what does it mean for us? It means Monaco. There is the Monaco Tools portal that describes it, right? I would say whenever you do something online that has to be code, we should have a component for you. This can be an editor, a smart diff widget, it can be a workbench, it can be even a service. Okay. Here's some examples, right? That's a widget that's used by TFS, the diff widget in the back, right? That shows you smart diffing. Commenting, that's all using, for instance, components from us, which is the editor widget, which is used also by research for things like playgrounds for research languages. Very popular, the TypeScript playground that everybody, I guess, from us uses from time to time, which is, I think, the smartest playground on the market because we support refactoring, reference searching, and so on, since for that we can reuse the language service from TypeScript. So we get all this intelligence in the playground. Azure uses us, the editor, for some validation of JavaScript. And Napa is currently the largest consumer from us when it comes to components. And they support that you write Office extensions like you see in the bottom right, like you can write widgets using HTML5 that access data from your Office documents. And that's the largest one. But rather than show you Office 365, that's what I showed at JSConf. Let me show you a little bit of Monaco, what we do and have today, and also show you some of the newer features that we have for TypeScript built in there. Okay, so here you see that's monacocloudapp.net. That's hosted on Azure. Everybody can log in with the Microsoft email address. It's only open to Microsoft email addresses. You see here Monaco itself, the code. You see some features we have, like We also warn you about unused imports because we really like that, because we want to have the imports in order, so that's you warn you when you don't have one. Also, very cool, we are on 0.9 now since last week. So, and the samples we have, they're updated to use generics, as you see here, right? You see some other nice features we have, like this quick hovering, control clicking, and so on, quick navigation. So what we do is things we like to make us more productive, we add to the tool, because we really do all our development using Monaco inside Monaco. So I said that unused import, control hover. We're big on comments, right? JSDoc comments, you want to make that easier. So let's, for instance, go here and look at the editor, right? This is the API of our editor. To make it easier to add JSDoc, right? We support that you can just type it as it flows, which we like. It makes our documenting so much easier. We also profit from the incremental behavior of the model. So once the model is set up, we get much faster turnarounds, and we leverage it also for compiling. So Monaco is about 1,000 files, 200,000 lines of TypeScript code, and we do incremental compiles. So when, for instance, let me go to the build view-let, remove this unused import, and see there is a build will be triggered automatically in the top left corner, and watch how long it takes. Build starts and is done. So there's an incremental build, and we leverage, of course, the TypeScript language service, and we really generate the code just for the change. And we update the language model and then generate all the code from the language model. And this takes really on the order of 2 or 3 seconds, right? Yeah, you see 2,000 milliseconds. Okay, so that's just to show you a little bit where we are. What we also did, we tested, could we do TypeScript in the cloud? So we have set it up, right? And this, for instance, shows you here. TypeScript on Coplex supports Jake. This supports the Jake build, and so on. And that's all running hosted in the cloud. Okay, so that much just to show you context, what you work on, and that justifies why you have 200,000 lines of code, right? There is some behavior in there. Okay, so let's start with our journey. We have basically 3 phases of development. I think one was the warm-up, the getting started. We're still small. Then we have grown, significant growth, and then the last one is when you have become large. And what we notice is during different phases, different patterns are important to us. Like during the startup phase, like module classes was very, very important for us because everybody needs these compensating patterns because JavaScript doesn't provide them. What I found very interesting, there is no compensating pattern for interfaces, so that's what you only could benefit from in TypeScript. I found this very, very interesting, right? Nobody has a good story for compensating patterns for interfaces unless you have something like TypeScript. Very important for us are promises, which I will not go into too much right now, but this was very important for us in the beginning because we want to manage our callbacks. And actually at JSConf, the cool kid on the block when it comes to promises is the A+ specification, which was a community-driven specification, and which really looks like it's taking off and being adopted. At the bottom, you see basically the adoption path of TypeScript, and we started slowly. First year, of course, we know a young compiler can drive you nuts because you have to find a code path to work around potential issues. So that's why we didn't want to have the whole team not being hit by that. So we started small, so 1 or 2 members of the team. More people got infected by 2012, but we still had critics by then. I must say, we have hardcore JavaScript programmers in the team, and they were critical. And it took them a certain size, right? When we reached more, then they really came begging, can I rewrite the editor in TypeScript, right? So that's when we got to 100% TypeScript. And that really shows, we didn't force, or I didn't force, or the team didn't force anyone to use TypeScript. You really want to, you have to buy in, right? This is not something you can push down the throat for someone. And the nice thing is you can do this hybrid development, even so it gets painful over time. So that was basically the startup phase, the small one, where we got up to 50,000 lines of code roughly, right? And for that, what I found the most interesting are interfaces, right? And what I did, I went through our code and looked at how we use interfaces, and I found it interesting. And even more interesting, there's even a blog on the TypeScript side that also describes all the different uses of interfaces, which I found in our code. Obviously, using classes to define the shape of classes, we use it. In particular, describing the shape of data options or JSON structures, we use it a lot. Right, we use a node on the server, so when we pass JSON objects around, we describe them as interfaces. And given that you have optional properties, it's very powerful to do that and very handy. All our callbacks are typed, right, using this invocable interfaces support, and indexed access is also captured as in interfaces, thanks to all this powerful interface support. And that's all some of the feedback I got when I talk to people, right? So some of the type person, they really said, yeah, I think this interfaces, structural subtyping is one of the more interesting things of TypeScript. Of course, they haven't seen 0.9 yet. Okay, very important, interfaces for external types. So when we started, right, we didn't have the definitive type library. In particular, for Napa, we needed to have types for the Office programming model because they needed to access from the Office functions in order to implement the extensions, and we use that behind the scenes. Now, when you do JavaScript IntelliSense, we leverage the type description from which were done in TypeScript. So you have a demo. So what I decided in the keynote talk, I want to show them some type definitions, and in particular, I want to show them jQuery because that's for me kind of the litmus test. If you have a rich system, a rich enough system to describe APIs, because jQuery is very fluid, has lots of overloading, lots of optional behavior. So what I did instead, I showed I did another playground, which I call the type definition game. So how it works is, right, this is playground. You can see on the left the type definition, and on the right a sample that uses the type definition. And the type definition game goes like that. You paste in the sample, you get lots of squiggles, and you don't get a lot of IntelliSense. And then you can start on the left to add type definitions, and the squiggles will go away, and you get the richer IntelliSense. So let's show this game a little bit in action, right? I added this CSS function method to the jQuery object, and the squiggles went away, right? So that's also how the type definitions on definitype.on, they have typically per library, you have 2 files, one sample and one of these type definition files. So because I thought this audience for JSConf, they were not yet ready for Visual Studio, so I showed them this all in the browser. Anders mentioned the community contributions, which of course pointed out in the talk as well. And now we come to the next phase. We have grown up, right? This was about one year into the project. We were at 100,000 lines of code. We were already self-hosting, dog-fooding all our development on Monaco, and have reached a certain size. So then we got into other patterns which become interesting, like AMD, lazy loading, that become important to us. So let's look a little bit into our challenges here. So we had the growing pains. I mentioned now we are about 800 TypeScript files. So managing this somewhere as a list of script is very painful, in particular if the script have to be in the right order. That was a pain point. We started to use internal modules. So we used actually for the JavaScript, use Win.js, the define functions provided by define class functions from Win.js, and for TypeScript use internal modules. And what we find, it's very easy to import an internal module, and it's also very easy to contribute to an internal module because these modules are open. So, and over time we noticed we saw some rot, right? We had cycles, the namespaces were coming from everywhere. Any similarity with the file system structure was purely coincidental and not there anymore. Also, I found some interesting quote from another project. Our dependency graph was such a mess that each R had a dependency, not just about every other area. So we were in a similar situation, right? The dependencies were just very hard. And internal modules, they give you namespaces, but not a strong mean to express dependencies and manage dependencies. So what can we do? Well, the nice thing is there's this AMD standard with different implementation. AMD stands for Asynchronous Module Definition, which came out of the Dojo library. So they did several attempts. So the first definition was wrong, and they got a second one, which then eventually grew into AMD and also was standardized as AMD. And the nice thing is it's basically one function that allows you to define a module, its dependencies, and it's asynchronous. Asynchronous, so gives you a callback when the dependencies are resolved. So we used that for Monaco. We implemented our own loader. Two reasons. We first wanted to really understand AMD, and I think that's really helped us. Second, we want to have the option to be open source free, right? The standard AMD implementation, which is open source, it requires JS, but you want that the core of Monaco is open source free so that we can also ship as part of Windows. TypeScript supports external modules, and that's where we're collaborated intensively with the TypeScript team, because we use Node.js, which uses common JS modules. We use lots of browser code where we used AMD. And the nice thing about TypeScript is they give you one syntax for different module systems, based on a command line switch. You can then generate either an AMD module, which generates a define function, or you can generate a common JS require definition. So I'm using here the 0.9 syntax. The pre-0.9 or the 0.0.81. So I saw the new one also allows you to even use the require word here, which makes it even closer to the common JS module definition. I just noticed that before the talk. So what was nice now in JavaScript, it's really painful. The define function is pretty complex because you have a long list of dependencies. For each dependency, you have a callback when it's resolved. It's very painful to maintain, and TypeScript really makes it not much nicer for us, for both on Node.js and in the browser. So we like that a lot. So the next challenge for us when we want to support a la carte consumption, what I mean by that, we support different components, and we know some of our clients, they want to have just a subset, right? Or they don't want some components from us. So that's why it's very important that we have modular parts of everything, which means we can easily drop a part, or if someone doesn't want it, they just remove one dependency, they repackage it, and they only get what they require, thanks to the fact that all dependencies are here. So one challenge is CSS, right? If you want to have something self-contained, you also want to have that the CSS or the NLS bundles come together with the module. So what we did, we added an AMD loader plugin. So AMD supports plugins that you can extend what it loads using some bang syntax. So we implemented the AMD loader plugin, and then we had to collaborate also with the TypeScript team again to give us a pragma that it will be also generate the corresponding AMD statement into the code. And that's kind of the AMD dependency pragma we can use to express that you have a dependency on a CSS file, which will then generate the code for it, which will then trigger our loader to load the CSS on demand, right? So the cool thing is we are really modular, and our modules are self-contained. So some more growing pains, startup time, right? We load lots of scripts and CSS, which means many requests to the server, lots of data transfer. So the pattern we got into here is lazy loading. So when we contribute things, we want to only load them as we need them. And that's kind of best viewed as this iceberg picture, right? When we start, we only want to load the tip of the iceberg, which provides us enough information about the contribution, and we load the heavy part only when we need it. So an example, we don't want to load all the language services for each language on startup. We want to only load them when you open an editor of this particular type. So what we do is we have this split into a contribution and into the body part, and the contribution gives us enough information to know what the contribution does. In this case, now I can handle C# file, and we describe it how to load it, right? Which module and which class to instantiate. So this works for both JavaScript and TypeScript, but it looks just nicer as usual in TypeScript because we can just name the class here and not just the constructor function and so on. So this was really important for us to improved the startup time because we only load language modes or viewlets as they become visible and not eagerly. Everything on startup. So that's the lazy loading contributions. And I would say it took us about 2 months to migrate our 100,000 lines code base to AMD. It was real work. We not only had to just convert the code, we also had to organize the file system structure because now our namespaces correspond to the file system structure and so on. So we really know now where the code belongs. And that's a nice comment from one of our developers after we had done this AMD migration. And he said, I really feel like fresh showered because it's self-contained. You have no more cycles, no more globals, and you have a clean file system structure. So that was a good thing, but it was costly. Okay, let's go to the last phase when we got the 200,000 line, which was recently. Then we had to use some other patterns, like we had to start to use components and also dependency injection. So let's do that step by step. And also notice in this phase, we went from 50% to 100% TypeScript. So we are now fully converted both the client and server to TypeScript. Well, to be fair, we have, I guess, our scroll bar code is still in JavaScript because nobody wants to touch it. It's so subtle code. So we rewrote it in TypeScript, and that's kind of, Alex was the one that resists the longest. But at some point, he also came and said, well, I really feel like JavaScript is, in a large project, it's like carving code in stone because he couldn't change it anymore. Now, and the editor had tons of requirements along the path, right? We had to support Chinese characters, which means you had to rewrite the view rendering because we haven't done that from the beginning properly. Then came to the F12 tools. They want to have long line support. We had to re-implement the view model and so on. And all these refactorings required some agility when it comes to code changes. And we couldn't do that with JavaScript. So for that reason, we decided we rewrite it all in TypeScript. So this took us time. We didn't do it automatically because, as I mentioned, interfaces are a very powerful abstraction from TypeScript, and you cannot generate that. And we intentionally say we do it manually, and as we do it, we add interfaces and use TypeScript as good as we can. And the speed is not that impressive, right? Typically, you have 300 lines of code per hour. So that's, but as I said, it's not only just migrating, it's adding interfaces to describe structure, the shape of things, and so on. And that's in the comment from Alex, and I found it interesting. He realized how inconsistent he was in the JavaScript code because his data was flowing in different formats, right? Because he didn't have an interface to describe the shape, he was inconsistent. And also we found stupid typos and so on. It was a very healthy exercise. So then the growing pains come, the tooling slow down, the translation time goes up. I showed the incremental build which we do, which is cool, which helps us. But still, no, we know we are now about 1,000 files, and we cannot assume we can always compile and deal with 1,000 files. So we need to componentize them. And what we do, at least for now, we use, for instance, TypeScript as a component. What I mean by that, it's like kind of binary JavaScript, right? We just have a declaration file for the language service from the compiler we get from the TypeScript team, and we don't recompile and build the TypeScript compiler, right? And the nice thing is TypeScript supports this componentization by giving you a way to generate these declarations for you, right? You can generate the declarations that generate kind of this binary JavaScript. So, and that's what we use, and we will use that more. We know we have to componentize the rest of our structure, like into the base part editor, so that we don't compile everything, but just, for instance, the thing you depend on. We're not there yet, right? So that's something which is on our backlog. Dependency injection. So that's interesting, right? Because that's hot in the JavaScript and C# communities. And I was thinking, well, we never need something like that in JavaScript or TypeScript because that really comes from these cultures. But what we saw is that our code become harder and harder to test because you have typically some container, in our case the workbench, right? And you have a viewlet or the editor. And when you write it, you need some services provided from the container. Now this has testability challenges because whenever you want to instantiate an object, you need the container, which is the workbench, which is a heavy object, right? So for this reason, what we did is we identified the services, and the idea is then we have an injector that injects implementation of these services into our code. And through that, we get configuration flexibility, like Nappa can configure our workbench differently with different services. Then we use it for self-hosting. So how we do it we use, of course, interface again. We define a service in an interface, in an interface, like for instance, the progress service, which is typically coming from the workbench when you want to show progress. We have a way to express that you want to use this service, and then when you actually do it in a class, right, you say that you implement this service, you have a reference to the service, and we use setter injection that can actually inject this service at runtime. Okay, so that's how we do dependency injection. Again, leveraging interfaces to make it more explicit. Of course, behind the scene, interfaces are totally erased at runtime, so the injection actually is based on names of this function, right? That's just truth in advertising. Okay, so I come to the retrospective. From the beginning, I knew we were on the bleeding edge, that we were prepared for it. We would do it again because the benefits outweigh the pains. And also, I would say, building the code base we have and having it in such a fit shape wouldn't be possible without something like TypeScript. Right, all the refactorings we had to do because we continuously refactor the code because you always want to be fit for changes, right? We cannot afford to let the code rot. We couldn't do that without having TypeScript as our safety net. It gives us coding agility, refactoring agility, and of course the good tooling, IntelliSense that I've shown before. So what I would change, I guess, I would say we would start with TypeScript and AMD from the beginning, which would keep us and help us to reduce kind of these refactorings, these major migrations we had to do to get there. I must say though, for smaller things, I still like also JavaScript because I don't have a build step in between. Okay, so this was the message I delivered, and then of course the overall theme was increasing developers' delight, and I hope that came over. So that was what I showed. And then, of course, I refer them, try it out, it's open source, and so on.
Awesome. So before we let Eric go, does anyone have any questions for Eric? Brandy? You need the mic so he'll hear you.
So Eric, I'm glad to hear that you managed to do some things while saying OSS clean. I was wondering, I think someone's mentioned it before, but do you have that OSS clean AMD loader available
Yes.
for others to use?
Yes.
And actually, send us all a pointer to that?
Sure. So we don't have it. You have to pull it out of a zip file, but we can point it to. But the TFS Web Access team is using it, and others are starting to use it as well. Yeah.
Oh, okay. It would be great to get that in a common place. Thanks.
Other questions? I have a quick one while I'm passing the mic. Eric, are you guys still compiling with the strict mode for the compiler?
Yes. We generate strict mode. Yeah. What we noticed though, the packager we are using kicks it out. So now we use the R optimizer, and R removes the use strict statement. So we had to do something now. We changed it now since last week that we preserve the use strict.
Oh,
the
well,
12 team wanted that.
So there's that strict, but what's the switch that forces like no implicit any is the switch that I was actually thinking of.
Oh, so yes, I think this switch, unfortunately, since we're on 0.9, this switch is gone.
What?
We're putting it back in.
Oh.
Well, Cyrus or someone else can tell me, but I think it's gone. But you're right. So we are purists. We run with the, before we were on 09, we run with the switch that we had the green squiggle when a type was resolved to any.
So,
okay. Question.
Just to add to that, so we basically had a no implicit any in 08 that was kind of an experimental flag. Now I've got it turned on. We're good.
Okay.
Yeah, thanks though. That was an experimental flag. We wanted people to try it out and give us feedback. We took a bunch of that feedback and have now designed a no implicit any that will be what we support in the 1.0 TypeScript. And I'm not sure if it'll make it in for 0.9.0, but it should be in there for 0.9.1, which will be the succeeding release after this current one.
Yeah, we're eager for using it, right? So Because now we have all these settings, right? And the TypeScript ones. What do we set for TypeScript? Yeah, that's just ours, right? We don't have the implicit anymore. Yeah, okay, we will be ready. Jonathan, whenever you give it to us, we'll use it.
Okay, so next question.
Hey, Eric. So your point about dependency injection was very interesting because we have been looking to do something very similar at Bing. So my question to you after seeing your implementation is, why not just use the AMD format, which already specifies dependencies on external modules, as your dependency injection mechanism? Like, why do you guys feel the need to have another implementation?
We looked into that, and I think if you read the AMD community, one of the first things they write, don't use AMD for dependency injection. So I forgot about all the history, but we use dependency injection really as a high level, like only for managed objects. Right? We don't use it at a very low level. It's really for the high level objects. So, and we think what we have is more explicit, because you want to explicitly define the interfaces and also how you consume that. That's more explicit than just having a dependency in AMD, right? It's a stronger dependency. It's a service dependency and not just a code dependency.
I see.
But it would be interesting actually to go deeper on this discussion. If you please follow up on us with that.
Sure. So for Bing though, the particular requirements we have sometimes is, we have a module, but we have a different implementation of a module for a different market or for a different device. And basically what we were looking at is we have a dependency on a module, but we do want to load different implementations of those modules at runtime. So that is why we were looking at dependency injection via AMD.
Wasn't that something that Steve was experimenting with? The module implementation stuff?
Yep. Thanks, Eric.
We had another question, did we? Oh. It should be on.
Yeah, Eric, a small question on your boot up or startup script size. Do you know how big is it, or?
I would have to look it up. So I would just look at the network tab.
So do you know like what kind of startup times do you get, for example, on our first device?
Yeah, we had a table. So I stripped it out from the talk. So I would have to do it again, right? Yeah, see, yeah, you need to digest and massage these numbers. I don't know whether you still see my screen.
We can.
You can. So, of course, now it's cached, right? It's.
So
it was 300 milliseconds. 300 milliseconds, I guess. That's what we had. Yeah.
So one of the things that we saw, like if you
see, that's the load. That's the main. And the main is. Yeah, it's from cache. See, okay, it's in the cache, right? So I don't see the size of that's our main package thing that we load, right? But it's 300 milliseconds, 400 milliseconds until we get what does the red line mean? The page is ready.
Okay. And do you know how long does it take on Surface to boot these things up?
Luke has done a prototype to bring it up on Surface RT, but I haven't done it on Surface Pro.
The Surface RT is what we were looking for.
So Luke, do you have memories how long it took?
The one I did was as an app, so there was no network time, but the load was reasonably fast, but I wouldn't know the exact number.
We haven't tried it on Surface.
So what are you looking for? What's your concern?
So essentially, one of the things that, at least in Nova, when we were playing, our script size is like pretty much bigger than yours, or like twice as your size. And one of the things that we see is like the dynamics change quite a bit as soon as we start talking about mobile devices, where even the member variable names being non-modified gets in both in the size of the memory and also the size of script. And parsing script itself becomes too slow on these devices.
I'm confused. You say not minified? We of course minify ours.
No, minified as in like, let's say if you have a member, what you minify is like you minify
one. You mean the exported
scope variables. You don't minify the member variables or member fields or methods. Or do you?
If they're exported, right? Yeah.
Right.
Then
And-
you can call them.
And those are the things like if you have a...
Okay.
So, anyways.
Namespace
Got it.
mappings don't get minified either.
Yeah.
So that's why I was querying, like, did you ever check on mobile devices, any one of these, the performance and everything?
Haven't done that yet, no.
So any other questions? I have another one. I noticed that you had Chrome running. Do you do primarily debugging under Chrome?
No, I guess Steve can explain why I use Chrome, right? There is a chakra hiccup that hits us. I could have done IE. If I would have done it on IE11, then you couldn't have projected it. On IE11, I use IE. But IE10, Steve, maybe you have all the details.
Oh, there you go.
Source map.
No.
The source maps don't work right under Chrome.
Is this on? Oh yeah. Okay. Oh, there was a decision made for IE10 to ship some choices in the heuristics that the Chakra engine does that were not optimal for that particular language service. So I can see why they were using Chrome, but it's all fixed in IE11. What's shipping in blue, and we verified that there are no further problems with IE for the TypeScript language service in Monaco. So there shouldn't be any problems going forward. So it was actually, we actually knew about it and went ahead and shipped IE10 that way because basically there wasn't anyone outside of the Monaco team that was likely to be affected. So, but for Blue, there will be. So because there's now Monaco being used in various products across the company, so it'll be ready.
So follow-up question to that is no debugging coming to IE anytime soon?
What do you mean by that?
Source map?
Well, today you have to do, Node.js. You have to use Chrome typically to debug Node.js apps.
No, you use Node Inspector, right?
Yeah.
Which is independent of Chrome.
Oh, okay.
Of course you have, Node Inspector, then you use the Chrome UI. You're right.
Right.
So there is actually on that, there is also Visual Studio extension that supports Node debugging.
Oh, awesome. Awesome. So any other questions? Okay, well, great. Thanks a lot, Eric. It's an awesome talk. Okay, so if you're watching live and you want to send questions for the guys, just you can email them to me and I'll ask them for you. So start off, anyone have any questions? First question? Perfect. It always takes one person to get it wrong. Go on.
So the thing is, we've been using TypeScript to develop our C1 apps for our retail customers, like point of sale, across different devices. And one thing that we've came across is unit testing. So we have TS unit, but then again, TS unit doesn't support asynchronous calls on the unit test. So I had to change the framework to support that, but it still is not quite there. So do you have any plans for extending TS unit on that regard?
So I'd say, is this on?
Yeah, you can.
Okay. So we don't currently have a plan on the TypeScript team to build a unit test framework ourselves. And I think generally within the sort of JavaScript tools team that several of us work in, we're not currently expecting to build a unit testing framework. There are several good unit testing frameworks, and most of the JavaScript unit test frameworks do work well with TypeScript. We intend for that to work well. I think Erich's team uses QUnit, for instance, and that works pretty well. But Ron also, who is actually, I think, doing a talk later this afternoon, has a unit test framework that he's built that I think you use internally, do you? And so maybe during his talk you can ask him about some of the unit testing stuff he's done, but that I know supports asynchronous calls and several other things you mentioned. So.
May have to be after his talk. He has a lot of stuff in his talk.
Right. And I was just going to add that Chutzpah also has TypeScript support built in now. It might be.
So for VS integration in particular, yeah, Hejlsberg gives you VS integration into the unit test runners.
So, next question. Anyone? Oh, Brandy?
So Andrew's numbers say there's been quite a number of forks. In my experience, usually when you fork a Git project, nobody actually changes it. But I know there have been at least a few forks which have added significant features or have gone some way. I was curious the extent to which you guys have been tracking that and the extent to which you're actually open to bringing those in, assuming that they meet some quality bar. Personally, the only one I've seen which looked pretty interesting, I would be surprised if the author's in the room. I'm pretty bad with names. There was one which added Python-style decorators that would have made some of the...
that talks
so when are we getting that one in, right? That would make my test look a lot better right now. And in fact, looking at what Erich was doing, some of the pain that I think he was hitting, in Python, for example, usually that's whenever there's some kind of introspection gap. That's the first thing I jump to. And as far as, how are we going to know what interfaces I actually need to inject into this thing with his dependency injection example? It seems like there's a lot of utility there. That's just an example, though. I was just wondering how much are you looking at it in general?
So maybe something to go along with that. One of the things that we're really focusing on now for 1.0 is really driving the language and having a vision for the language that we can carry all the way to 1.0. We haven't taken external contributions, you may have noticed. And part of the reason for that is this focus. After 1.0, I think we expect to open things up quite a bit more, start looking at these language features that could add a lot of bang for the buck, especially if they're already kind of tested in their own playground, and then incorporating those in.
Yeah, there's other than the technical aspect, I'm sure there's a legal aspect to it too. That if we have internal teams using TypeScript in projects where we are more concerned than others with taint and whatever, and so I'm just pointing out that there's some other issues that we consciously have not focused on currently because we just want to drive to 1.0, have a coherent package, and then we'll revisit all of that.
So I think there's sort of two halves to the question. One is about just general accepting of contributions, and then the other one is about some of the specific things that have been done. So I think obviously Ron has a couple of forks that he's worked on that have added really meaningful new features, which I think are really great as we can get experience early on. Like he's built them, but also has been using them himself and some other folks. And so being able to get experience with how those look, how those work. I think that's really valuable input when we do get post 1.0 and we can start looking at those features as potential future directions. Then we'll have a lot of experience from the get-go. That's all the features he's also been looking at are things which are being considered as part of sort of future ECMAScript directions as well. And so that's information that we can bring into those discussions. So generally using TypeScript and forks of TypeScript as sort of a place where we can do a playground for sort of experimentation on top of the language. Learn about things is a really great tool. The fact that it's open source, the fact that we can have all these forks, even if we don't actually take those back into the main product, it's still enormously valuable for us and for everyone who's using TypeScript.
Another example of that is generators. Yep. So there have been forks where people have experimented with.
Which is also
fun. Well, that's Ron's wrong. Yeah.
Awesome. Thank you. We appreciate it. So that's another thing for the post 1.0. That has the additional feature that it would make the code generation reasonable for something like async. So if generators were in the language and we could emit them to ES6 generators, for example, then it would be a much shorter step from there to doing like an async pattern. So we're paying attention to these forks, and we really appreciate the experimentation. And we're probably the next, like between now and October 1st is a time when there'll be frustratingly little progress and stuff like that. But what you will get on October 1st is really rock solid, stable 1.0. So that's what we're driving toward right now.
Well, that sounds good. Thank you for that. Let's hope Ron picks a really permissive license.
Well, you kind of stole my question. My question was going to be, you're almost out of numbers, so 1.0 is the next. Well, you essentially.
Well, actually, there might be a 9.1. I mean, 091. Yeah. But.
Yeah, and there's kind of a large infinity of real numbers.
9.5, 9.8, 9.82.
divisible.
Yeah.
So another question. Okay. Well, I'll give it to Ron, and then I'll bring it back this way.
One of the things that I've noticed with the 090 branch is that while it's using a lot of the new parser and new scanner that's being used and the pull type checking system, but it's still leveraging the older emitter. And I noticed that there was some progress being made on a new version of the emitter that supports rewriting in a pretty printer. And I'm kind of curious, is that something that's going to be done by 1.0, or is that something that you're still going to be leveraging the older emitter until that one's ready?
Cyrus can probably.
Yeah, it's like Cyrus, come on up.
Yeah.
Yeah, so the plan of record right now is, at least for 1.0, that you're going to see kind of what we're currently doing, which is reusing the old emitter technology. The new one that you saw, the pretty printer and the emitter, were kind of done as experiments, prototypes about what could be possible, and I think they're definitely the direction we want to go to. Just in terms of time and scheduling, we've wanted to reuse as many assets as possible because it allows us to rev things without having to destabilize a lot. So the core goals right now are just getting the language done and getting that all out. And then I think post 1.0 is when we'd like to see that come in, basically. Okay?
Well, one of the sort of user-facing things that would support, for instance, is right now our code generation. We try to be very sort of have the output look a lot like your input, but there's a lot of places where we don't exactly preserve white space and that sort of thing. And one of the key pieces of this work was to try and be able to correctly preserve white space and those sorts of things.
Yeah, at least internally, what's interesting is we completely understand. We know all your comments and everything, and unfortunately, because of the old system doesn't have that, we end up losing it and formatting it in one specific way with that. But it's what we want to do going forward, when we have more time. And it will simplify things as well because we'll do less translation, and there's a lot of good benefits to it.
Pass it this way. Thank you. There you go.
So we really want to migrate to 0.9, but I spent a whole afternoon trying to do so, and we found that our code has a lot of places where we've fallen outside the spec, or we see things that are like, wait, that compiles and works. And so we've had to push it off a little bit. What are some good long-term strategies so that we can not actually add even more problems as we develop features along the way until we can migrate?
Well, I'd say this particular transition is it's going to be the sort of last of these things where we're making big changes like this. Like as you sort of pointed out, like a lot of the impacts that this the transition from 08 to 09 has is that we're actually now correctly implementing the spec, and that has one of the side effects of that is that a lot of things which we accidentally were not erroring on, we now error on. Some of those, probably as you hit them, you'll say, yeah, that's clearly what it should have been, and we just had a mistake in our code that wasn't being caught before. Some of those, you may say, well, maybe that could have gone either way, but we are being stricter about that. So I think that's happening now because we're actually trying to lock down, sort of getting towards 1.0, making sure that we have a spec that describes exactly the same language that the compiler implements, so that we can explain the language to people. And I think that's in this phase. I don't think we're partly doing that so that we can get to a sort of supported, backwards compatible language and compiler for 1.0. And so you should not have any experiences like that post 1.0. But this 08 to 09, we do recognize there is going to be some of that in this transition. So folks, I know we've sent out some of the 09 drops early. We definitely want to get people's sort of experience on those so that we can feed that in. We do recognize that doing that, especially now, is going to be a little bit more work than hopefully it will be after we get it out more broadly. But we certainly appreciate being able to get the feedback. It's enormously valuable for us to not put that pain onto all the people who are getting the bits and actually have it on just a couple of folks internally who can give us that feedback quickly.
So on that point, I think something that would have gone a long way for us to make this easier, since we have actually done something like Erich in that we have some larger components with the binary JavaScript with the JavaScript file paired with declarations. We actually have a number of pretty coarse-grained projects with dependencies between them that generate these JavaScript declarations pairs. We would have been in a position to do a fairly incremental migration if there was compatibility from point 8 to point 9 with the declarations files, because it looks like there's a pretty, I think it was just a really minor aesthetic difference where the new compiler will not take declarations from the old one. If there was a secret style flag to just change that one thing, we would be able to do it project by project. I don't know if other people have hit something like that.
Well, one of the things I should say on that, probably the main change you're probably thinking of is that we now do require you at the top level to say declare.
Exactly.
It used to be that was implicit
in
a D.TS file. Now it's legal in 08.3 and in 09 to put declare there. It's just that it happened to be the default, or it happened to be implicit in 08.3. So for that particular one, there should be something you can write in your code which will work in both. So you might have to make some changes from what you had in 08.3, but you could get your code base to a place where it could compile with both compilers.
Do you still disallow like code in D.TS?
Yes, yeah. We always
But the thing that's different from 08 to 09 is that in 08, D.TS's were actually a different syntax than TS's, because in TS's you couldn't have a declare, or you could, but in the others you couldn't, and it was so they were almost the same. In 09, D.TS's are a strict subset of the main language, and we wanted to get to that point just so we didn't have to describe two languages.
It's all about Anders having to type less in the grammar.
But generally, I would say along that goal of being able to do the migration, we definitely have seen that one of the important things is being able to bring code to a place where it can compile with both. And largely that is the case. There's only a much smaller, of the whole list of breaking changes you would see, a much smaller list of those are things which cannot be made compatible.
Like Boolean. Well, I guess even that.
But that one even doesn't error unless you flip a flag.
Modules as types.
Yeah, and in this case, I think what Rick was seeing was the generated declarations from the declaration switch for the old compiler is not compatible with point 9.
I see.
If that was fixed, then our generated declarations, which we generate on build per project, would allow us to do this project by project, is my point. So if you guys would be willing to accept probably a very tiny patch for a 0.9 compatibility emit thing, then that would probably help us out.
That's a really good point.
Yeah.
Yep.
Yeah, Boolean.
Well, bull to Boolean shouldn't give an error unless you flip a flag to explicitly ask for it to give you an error.
Well, we were going to upgrade to the 0.9 jQuery, and Boolean is not defined in 0.8. So what I've done is installed the 0.9 language service while still using the 0.8 compiler. And so I can see, you told me not to do it, but I did anyway. So I can see all the errors that will occur in 0.9, but it still compiles in 0.8.
Nice.
So you may have touched on this during your talk. I was trying to field other stuff happening. But what's the ECMAScript committee's reception been to things like generics and so forth?
So I guess, so we have done a few rounds of kind of showing off what we're doing in TypeScript in the ECMAScript committee and in meetings. Generally, the group there is very positive on TypeScript. As all up, I think as a technology, I think the direction that we went of not trying to replace JavaScript but build on top of it, of actually taking some of the ECMAScript 6 features and making them the foundation of how we approach things has gone over.
So are they completely against CoffeeScript?
No, not against CoffeeScript per se. I think CoffeeScript also, because its philosophy is some similarities. I think they're more against things like Dart, things whose agenda is to replace JavaScript in the JavaScript runtime. But I think there's a lot of support for the direction that we went with TypeScript of being incremental and adding on top of it. And I think the notion of bringing a sort of type-focused way of thinking about coding for large-scale development is a recognized good. It's not something that is necessarily ever going to make it into the standard, but there are actually some people not even us in the committee, who are sort of pushing for that direction for future.
Well, there are
evolution.
even some who are using TypeScript to
Yeah, and that was another thing.
describe APIs to be standardized.
Yeah, so one of the other interesting things happened. So, like inside companies like Google, we've seen people using TypeScript, which is always interesting when people building a lot of the technologies that we consider sort of competitive technologies in the space are actually using TypeScript. One of the really interesting ones is the one Anders mentioned. Some of the folks at Google who are sort of doing a lot of web platform API specification and trying to build out new pieces of the platform are actually starting to write specs effectively using TypeScript. So writing sort of implementable specs as a way of describing the type surface area, which is kind of akin to what they do with WebIDL for describing these specs. So we're seeing that sort of start to show up in some of these forums, and it's starting to become more commonplace to use TypeScript as a formalized way of describing APIs up front, both in the sort of ECMA committee, but also in the broader kind of web committees. So one of our goals there was kind of to turn TypeScript's type system into the sort of somewhat de facto formalized way of thinking about types for JavaScript libraries. And I think we're seeing really good pickup on that direction.
Other questions?
Well, one more encouraging example on that was there's also been instances where people would bring up topics in the ECMA committee, and then other people would say, well, what's the TypeScript evidence? Like, how are people using this in TypeScript and stuff? So that's another indication of integration in the thinking.
And actually, one more along those lines. One small feature was added to ECMAScript 6 because of what we'd seen in TypeScript, which is statics in classes. It wasn't originally part of the class proposal. We had it in the TypeScript class approach. And when it sort of came up as a, hey, this has been used a lot in TypeScript, should it be in JavaScript? And there was general support for that. And then the choice of the syntax for it was sort of, because we had it in TypeScript, we had a syntax there, that was the obvious candidate. And so I think we were able to use TypeScript as precedent. And that's one of our other goals in the standards, has been to put TypeScript in a position where it is the precedent on which standardization can happen. So one of the things that feeds into how we think about where things would go.
That's awesome.
So is there any plans to add syntactic sugar for asynchronous programming constructs like promises and reactive?
So we would love to do it. We're not going to do it in 1.0. I think the biggest problem we have probably in 1.0 is that for all but the very simplest async methods you'd write, the code we have to generate is completely unrecognizable, and to some people appears to be a bowl of spaghetti, right? And we've sort of had a mantra in the team that we generate simple, beautiful code, and you can immediately see the correspondence between what you wrote and what got emitted, and we would break with that. Now, if ECMAScript 6 ends up being ratified with generators as a language feature, then implementing async on top of generators is much less intrusive on the emit side. And you can actually emit code that using a generator for an async method that looks very similar to what you would have written, and all we really add is the types around the various yields out of the generator. So that, I think, would be a very natural feature to consider for TypeScript. But it's not going to happen for 1.0, not just for these reasons, but also for schedule reasons.
I think Ron this afternoon will show you some of what he's been doing, which is exactly that path of building async on top of generators.
So one thing on the Chakra side, we're putting generators in the first wave of Chakra implementation for ES6, assuming it continues to be, it seems to be fairly stable in the spec at this point. And so we're planning to do it on the early side, and so therefore this path of future post 1.0 TypeScript doing async on top of generators will be something that IE will support on the early side.
Awesome. So, other questions? Well, I think we got time for probably about one more. Okay.
Just curious, personally, what feature would you guys like to see in the language? Not stuff that's been requested by everyone else, but personally, what would you like to see?
Personally.
All right.
Well, basically, what is your own private fork?
Yeah. I'm actually fairly excited about the decorator stuff that Ron's been looking at, and we've had some conversations about that. I think classes and sort of general, these more declarative forms like classes that we have in the language are really nice things for sort of visually the way that your code looks. It's sort of structured in a nice way. And decorators give you the ability to gain back some of the flexibility that you lose with classes, but still have that nice declarative form. And I think there's a bunch of questions to be answered about how exactly that looks, but both on the ECMAScript side and on the TypeScript side, I think that's a useful tool to be able to gain a lot of the flexibility that JavaScript generally had, but have the declarative syntax.
I'd say other than async, which I think is something that I'd really like for us to do. Steve and I have had a bunch of conversations about sort of more meta-like ways of using the type system. You could imagine web services or whatever that have the ability to somehow describe their data or their schema, just giving us a JSON document that we could immediately just consume and make types out of. So almost like a JSON-like way of feeding types into the compiler. Today you can only feed them in by writing manifest TypeScript syntax, but there's really no reason why types are data too, right?
So I have code that does that. It
yeah,
JSON
and that also touches a little bit on this introspection stuff that you brought up and whatever. And I think there's tremendous potential there to do interesting things that we haven't even had time to touch on or even reason deeply about. So I think we'll probably try to think about that some more.
Yeah, the one that Anders mentioned is my favorite. That's not, definitely not contemplated for 1.0, but something that. So definitely the things that have already been brought up are my favorites: the async, the decorators, and the meta. Being able to understand JSON data as if it were a DTS file.
Mm-hmm.
But I'll say something about CSS. I would like to see.
It fits.
Our team spend a little time on CSS and the CSS experience and looking at people who are using the less language to program CSS and could there be anything more integrated between CSS and TypeScript where, for example, you get cross-language IntelliSense there on styles or just making it so, because CSS is the other big thing you have to write. HTML is kind of a dying breed because you're going to generate most of it dynamically at this point, so you're mostly writing JavaScript, but you're still writing a lot of CSS. Like if you look at the Monaco code, they've got 200,000 lines of TypeScript, but they've got thousands of lines of CSS. And so, too speculative right now to say what the specifics would be, but I'd love to see, to make some progress on CSS as well in this context, just to make it easier for the whole package of what people have to write.
I would add to that, though, that there is a lot of CSS, that's great, but there's also templates, like Jade templates and stuff, and that's an area where we do actually access stuff that I noticed tends to be very brittle now, right?
Yep.
We get strongly typed compile checks on the TypeScript side of things, but not in our templates.
Yep.
Mm-hmm.
Yeah.
Yeah, so have you thought of, like with the data stuff you're talking about, using TypeScript as kind of like a schema validation for JSON?
Mm-hmm. Yes, that was... Steve and I were just talking about it for lunch a couple of days ago.
It was very nice.
Like ways of somehow saying this JSON document must satisfy this type declaration.
And then it allows you cast it and use it.
Yeah, and it works both ways. So, like one good thing is if you had an annotation so that it could still be parsed by other JSON parsers.
Right.
But then with our language service, we could go ahead and give you the IntelliSense on it based on whatever ascribed type you had. That would be a nice. It would be a nice world. Then you'd be able to do really well-directed authoring of JSON, but also use it as metadata in the TypeScript world.
If you squint, there's kind of some relation there to optional runtime type checking. If you look at it that way. I find myself often writing some boilerplate at the beginning for, since this is an external interface, I'm going to be doing some of the same compile time type checking by hand,
Yeah.
similar schema validation, except very deep.
Yeah. We've talked about it a lot. It's funny. It was sort of, in a sense, it was the starting point for TypeScript was, and then we're going to have, validation of what you said. But it turns out that it's, as you know, it's hard to truly validate this. Does this function really meet this? Well, who knows? Well, it has the same name, and it looks like it has the same number of parameters, but then it sort of peters out. Do you know what I mean? And so So these guarantees are always going to be somewhat fuzzy, and then there's the runtime cost of them, that we're not too crazed about. Yeah,
but we do get a lot of requests, and it's an ongoing subject that people keep talking about with us about. Could you emit some runtime checks for a debug mode? How would that work? And we're definitely not against the idea. We're just. It hasn't been as screaming of a need as things like generics, because there's a whole set of library typings, which has been a big focus for us, that would look a whole lot better with generics such as underscore, and many of them. So even jQuery, for example, could benefit from generics. So it's on the list, but it's not as high as like getting because I guess, as Luke pointed out, one of the key things niches that is available for TypeScript to kind of fill is this one where the JavaScript community really needs some way of describing their libraries. And that's why we're really excited about this definitely typed development where the community has gone ahead and embraced TypeScript and used it to type libraries pretty much independently of Microsoft. And so that's been our highest priority is to tool that completely. But we certainly do think that there's a number of things like runtime checking, like another big thing that people always ask us for that we just have to wait on past 1.0 is breaking modules into pieces so that you can download them. Like doing dependency analysis, you can break things up. Like the Office team, for example, is really keen on that. So there's a number of these things that it'll be disappointing. They're not in 1.0, but we are thinking about them.
Yeah, I think they were doing some min cut kind of thing on the dependency graph to try to split it up, but who's to say how often that edge is actually used? So
it's not weighted by your dynamic data.
Right.
But SharePoint team does use tools like that, like Coffee Maker.
Yeah.
All right, one last question.
Okay.
I just wanted to add on to something that Steve said about templating and things like that. And I know this wouldn't be a 1.0, but maybe post 1.0, maybe 2.0. But as things like quasi-literals in ES6 they're still being kind of debated back and forth on some of the implementation details. But that seems like an example of where you might be able to inject things like templating and having some type of syntax. I'm not sure if that's something that you might also consider as being able to do. If you supported quasis, being able to do inside of the either the string interpolation or the replacement variable, where you can actually put in actual code is actually being able to get IntelliSense within that code that you're binding.
Right. Makes perfect sense.
Yeah, so I mean that we certainly like. So quasis is a bad name for just a string interpolation feature. So like a Perl or Python style.
Well, they're both bad names.
Right, yeah, sure. It's actually now in the ECMAScript spec it's called string templates, which is maybe a better name, but not very descriptive.
Call it backquote.
But yeah, so we would absolutely support it there. I think the really interesting one for templates is the templating systems that do templating inside HTML, and then you have a lot of sort of scriptish code that lives inside your HTML, and we actually have a lot of type information about that. If you look at sort of an Angular or a Knockout or those kind of models, we have a lot of type information which would be relevant to those kind of things, but we have no way of lining that up with the HTML side. So I think that would be really interesting. I don't know how that would work, but I'm sure there's something we could do long term.
Yep.
Okay, awesome.
Thanks. And I forgot, Andrew's got a chance too. I wanted to thank all of you very, very much. TypeScript would not exist without the people in this room.
Exactly.
The feedback has been absolutely essential to making a decent product, so thanks very much.
Okay. So